Yeah, so come join us to build stuff. I think me and Topher, we already kind of got an idea on the wall. Don't look at that whiteboard over there. That's our idea. Don't steal it.
Don't steal.
But yeah, it should be fun. Do you have to register, Car?
Yeah, so if you click that top link, if you RSVP, we'll save you a spot. If you don't, then you'll be outside.
You'll be out in the cold. Well, you'll be on the patio. We'll have a grill too.
Hey, what are the prizes?
Oh yeah, so it should be at the bottom.
Surprises on this
Scroll
website?
down on the main website.
Oh
The
yeah.
main website. Prizes. Oh man, we've got the most polished. Oh, best hack overall. 20 million sats, most polished 5 million, most ambitious 5 million. Ooh, a Chamain mint 5 million, privacy 5 million, and we won't even talk about the last one. That should just go into like privacy. 10 million for privacy. Edit. All right. I'll get started. The main programming. All right. So those of you who don't know me, I'm Nick Theile, software engineer at a company called Galoy. We're a startup in the Bitcoin space. So we make Bitcoin banking software, and it's all open source. So kind of the motto right here is we're decentralizing the banking system, one organization at a time. So kind of what I'm going to talk about today is kind of the Bitcoin Beach wallet and the Galoy stack, what we have to offer, and like why would you actually use it. But most of this talk will be in code, hacking stuff together, probably demos that won't work, maybe it will work. But it's going to be probably not technical at the beginning, but at the end it'll get very technical, just to warn everyone. So I guess kind of my story of how I started kind of here in Austin with Pleb Lab. I think I kind of showed up about 6 to 7 months ago. But really I met at Meteor, one of our coffee shops. I met our founder, Nicholas Berti here. And he was talking about the Galoy stack. And I kind of heard about Galoy. I'm like, were they the guys who made the Bitcoin Beach wallet in El Salvador? But anyways, I basically just talked to him. I pulled the code down from GitHub. I got it up and running on my machine within 30 minutes. We went to Capital Factory at the time. Pleb Lab was out there. So I just kind of hacked all day on the stack and just kind of got obsessed with it. And we were kind of joking around we should make a pleb bank. So that's kind of where this little meme came from, like Pleb Bank of Austin, come take it is our motto. But it's not a real bank, but it was just a cool idea that we had that was made possible by building on top of the Galoy open source stack. So let's talk a little bit about Galoy and the Bitcoin Beach wallet. So if you're not familiar with the Bitcoin Beach wallet, there's a town in El Salvador called El Zante, and they got gifted a bunch of anonymous money from some rich Bitcoiner, and they needed a Lightning wallet. So basically at the time, our founder, Nicholas, flew down there, and he said, hey, I'll build you a Lightning wallet for free. We'll build it on top of this software I've been working for on the last couple of years on Galoy. So if you haven't been down, has anyone been to El Zante or El Salvador? Raise a hand, anybody? One? Wow, okay, you guys, okay. These next slides will be cool then. Yeah, so if you don't know the whole story is they're kind of left out of the banking system down there. It's too expensive for somebody who lives in a rural village in El Salvador to get like a traditional bank account. So they were very heavy on cash. I'm sure a lot of you know like the Jack Mahler story. He was part of some of the stuff in El Salvador, as well as Galoy before they adopted Bitcoin as legal tender. So yeah, 2009 is when Mike Peterson went down there, kind of started the youth programs and computer classes. And then in 2019, there was that anonymous Bitcoin donation. And then 2020, Nicholas came down there and made the Bitcoin Beach wallet. I think a little bit after Jack Mahler was down there doing that stuff, which obviously Bitcoin conference 2021, I think, is when they made the big huge announcement about legal tender. Yeah, so here's just, I went there recently for the Adopting Bitcoin conference that Galoy throws every year, usually in the month of November. But you can see it's a beautiful beach. Like on the right there, I took that picture at sunset, and I don't know who that was, but somebody was flying in on a helicopter. I think it was somebody from Cash App. They were doing like a surf competition that weekend. So it was cool to kind of see that, snap that randomly. And then on the right is just me in front of the El Zante sign with obviously the Bitcoin in the background. Yeah, so there's volcanoes in El Salvador too. So if you want to do some sightseeing, you go hit some sunsets and volcanoes. And this is just a shill for our conference we do every year, Adopting Bitcoin. So it's a little bit different than some of the tech conferences and Bitcoin Miami. It's kind of half technical and just half about the actual people adopting Bitcoin, like for their day-to-day life and circular economy and just kind of how it helps them. So yeah, there's Dusty actually giving a talk on splicing. He's a local guy here. So this is actually our wallet. So we don't actually have our wallet on the App Store here in the US just because it's hard to make that happen legally with a custodial wallet. But it's available, pretty much everywhere else. It's a standard Lightning wallet with on-chain Bitcoin. You can basically, there's a map. Yeah, you got a question?
Do you know why Wallet Satoshi is able to make their app available all over the place?
I think they're riding dirty. Yeah, I think they're just flying on the radar right now. So I think, yeah, I wouldn't.
Based out of Australia, right?
Yeah, we actually had the conversation at our company a couple of days ago on this. But yeah, they're based out of Australia, and I don't know why. Like, I think they're just flying under the radar for now. So I'd watch out for that one. But anyways, a lot of the early stuff with our wallet is, we were actually making it for people in El Salvador who didn't know anything about Bitcoin, especially Lightning, when you have like 2 invoices. So we wanted to do like this earn sats to learn. So they can actually earn, I think, their first 100 sats or something, actually learning what Bitcoin is, how to use the wallet, why is this on-chain, why is this Lightning, just a really basic introduction to that. So this is a super high-level overview. I wouldn't even call it an architecture, just an overview of our core Bitcoin banking platform. So we have, like I showed earlier, a mobile wallet. We also have a web wallet and kind of an admin dashboard. Sometimes in Lightning, when a merchant uses it, they might get charged too high of a fee where we have to refund them, just blips in the network and stuff like that. We have an admin panel. We have our backend GraphQL API. We have basically multi-sig because we are kind of running a custodial wallet. You don't want to have all your funds on-chain in a hot wallet. You want to have multi-sig cold storage custody for that. So we have solutions for that. We have this thing called a synthetic dollar, which kind of got renamed to stable sats, if you're familiar with that feature we launched last year, but it basically gives people access to the dollar who don't have access to it. We're lucky enough we don't need that feature because we have access to banks if we need fiat, which Bitcoin's better, but sometimes you need your monthly expense with fiat. And our last thing we have is just instrumentation. We have monitoring, we have telemetry, tracing, all the stuff you need to run like a real production grade enterprise application with thousands of users. You start running into just having to operate your operations, and it has to be pretty slick. So just a really quick slide on the stable sats feature. This allows people in El Salvador to convert between Bitcoin and stable dollars. It's not a stable coin, it's totally different. Serves the same purpose, but a stable coin people are typically used to is Tether. It's issued by Bitfinex. But it's centralized in the sense where, even though it's running on whatever blockchain they use or Bitcoin or I don't know what they're using nowadays, the risk is in one party. So we're trying to split that risk up. So I'm not going to go into super big detail because there's a lot of talk about how this stable sat thing works. But essentially, the goal is you put the trust. And anytime you have a stable coin type thing, you have to trust some entity. So the entity we trust is an exchange. So we can actually split that up between many exchanges. Obviously, you have bad exchanges like FTX, but there's a lot of other ones. So right now, it's based on the OKX exchange, and it essentially just a hedge on both sides of a trade with Bitcoin. You long and short it, and it essentially can stay stable over time to give people who don't have access to the dollar, like Venezuelans, probably need it pretty bad, and obviously countries who are doing hyperinflation, this is kind of a useful feature for those people. So like I said, our stack is totally open source. Anybody can download it. They get all of those features I was talking about earlier for free. And there's several other projects that are using it. I talked about kind of the first project was Bitcoin Beach that used it. There's Bitcoin Jungle is another one who forked it down in Costa Rica. You've got the Brazilians with Praia Bitcoin. You've got Senegal and Bitcoin Lake down in Guatemala. So there's definitely a lot of implementations. I think I just heard of a Bitcoin mountain somewhere. I don't know exactly where, but just throw the word Bitcoin in front of anything and you can run it. So obviously a lot of us here are pretty technical, so we probably run our own LND node. We probably run our own LN bits, most likely on Umbrel, I think is the typical setup for somebody. So I'm going to kind of differentiate the difference between that, between like a voltage or open node solution, which is in a different class, and then Galoy is kind of in its own separate class. So typically when you run your own Umbrel node, it's on one single box, usually a Raspberry Pi. So that allows, not for like super big scalability, you kind of get into vertical versus horizontal scaling. So at that point, you can just vertically scale. You can add more CPU or RAM to your one machine. Eventually, once you max that machine out, you're kind of done, which is fine for an Umbrel or LM Bits because you're just hosting that for yourself, or maybe like the Uncle Jim model where you're hosting it for 100 friends or 20 friends, however. And that'll work pretty good. But once you get to a bigger scale, you'll probably move to something like a Voltage where they're actually running that in a cloud somewhere. They're kind of running the infrastructure for you. You don't have to manage or think about it. I know Topher's used it for some of his projects out there. Sats for Tip, I believe, is one that's running on Voltage with LN bits. And that will scale a little bit more, right? So you could probably get tens of thousands of users with that scale. But once you start getting bigger, you might have to move to like an open node, which is what a lot of companies in El Salvador use. Like when McDonald's and Starbucks had to adopt Lightning as part of the Bitcoin law down there, most of them just went with open node, which is a fully custodial node they manage for you. The code is closed source and you don't really know what's going on. But that scales obviously pretty good. They've got McDonald's and Starbucks on it. And we're kind of like on the far end of like horizontal scaling. So we use a technology called Kubernetes, which I'm going to do a lot of demos of that later. But that allows you to add just more instances. So assume this is running in like a Google Cloud or an AWS cloud. We can scale to tens of thousands, if not hundreds of thousands of users with our architecture. And this is similar to like what a Cash App has to do. Cash App, they're going to have hundreds of thousands of users, maybe. I don't know how many users on Lightning, probably tens of thousands right now. But that's a lot of the drivers behind them rewriting some of the Bitcoin and Lightning software. They wrote BDK, the Bitcoin Development Kit, to allow these more horizontal scaling use cases. Same with LDK. LND and some of these other implementations are a little more on the vertical scaling. You can kind of do like a load balancing, like a round robin situation with multiple LND nodes to get it to scale pretty big. But once you're on the size of Cash App, you're probably going to want something like an LDK out there. So yeah, that's just kind of the difference between the different architectures. So this is a super detailed view of like everything our stack offers. And again, everything's open source. It runs in the cloud, but it also runs on machines too. I'm actually going to do a demo of it running on this Intel NUC I have right here, if you can see that, which isn't a super beefy machine. It's a bit beefier than a Raspberry Pi. I believe this has like 8 gigs of memory, maybe 16, maybe like an i8 processor. It's like a $500 machine. So it can run probably on most of your laptops. But yeah, let me kind of go through all of our features real quick, kind of starting at the core here. So we run a multi-sig custody, like I was talking about with Spectre. We've got a Bitcoin D full node. And we've got 2 LND nodes because we don't want to have any downtime. So I'm sure a lot of you who run a Lightning node know about having to upgrade that, especially when we get these hot patches we got to do and like really quick because Barack puts a big transaction. We're still early days, so you got to patch your node. So we have 2 nodes for redundancy for that. If you go up a layer, we've got kind of our core products. We've got the stable sets thing I was talking about with the kind of the stable dollar situation. We've got a Lightning gateway, which we have a GraphQL API on top of LND, so it makes it a little bit easier to write applications with. And we've also got a core ledger, an accounting system. So similar to like LN Bits has an accounting system where you can do like an Uncle Jim for your family, we have an accounting system for all of our users. What are their balances? How much Lightning do they have? How much Bitcoin do they have? And that's all exposed to all the applications with this GraphQL layer. And we're starting to even get more of a different authentication layer. So we do want to support all different ways to authenticate with our app. Right now, we're pretty much a phone number and a Twilio code is like the easiest way in El Salvador they wanted to authenticate. But in the future, we want to support, passwordless auth where you just open the app like Wallet Satoshi, you just open the app and you're in. But there's actually like tokens and fancy authentication stuff going on under the covers to identify you. But it looks like you just open the app and you're using it. So I think we do start to want to get into those more complicated setups for authentication just so we can have different products. And really in the future, if some big enterprise or bank wanted to adopt our software, they might have some kind of authentication enterprise system that they want to tap into. Other than that, we've got a pretty advanced CI/CD pipeline. We run our own CI/CD. A lot of people run like GitHub Actions to do continuous integration delivery. We actually use a tool called Concourse. It's open source. We run all of our own CI ourselves. It's a little bit safer to store secrets and keys out there. And if you run your own CI, I believe Circle CI just had a hack I think about a month ago, where everyone had to rotate their secrets and keys. So you don't want to store secrets on somebody else's CI system. What else do we got? And we've got some of these continuous infrastructure tools. Like I was saying earlier, we run everything on Kubernetes. And this is kind of an interesting evolution of kind of the previous workshops. And we started kind of with Austin with some of the Pleb Lab stuff where he showed us React Native code, and I believe you pulled down LN Bits locally. And then you kind of evolved to what Topher showed us with Docker. We're running all this stuff in Docker containers and images on one machine. Kubernetes is kind of evolution of that. How do you run all these dependencies like LND and Bitcoin and all this stuff? How do you run it at scale for thousands of users, potentially in a cloud or maybe even on your own server, your own machine? And that's really where Kubernetes comes in handy. And on top of all this stuff, we have, like I said, mobile application, a web app, all that type of stuff. And you could even write your own custom Bitcoin app if you wanted to. So let's go into the demo. No more slides. I'll code from here on out. Or actually, yeah, I actually have one more slide. So the origin story of Galoy. So not a lot of people know this, but the name is actually from a tribe, the Gauls. So back in like 5th century BC, there was this Celtic tribe. They were like these decentralized people scattered around like this big, huge, centralized Roman Empire. And they were able to withstand, many centuries of not getting occupied by the Romans. So it's an interesting story that they're, where's the good line here? So they're basically like the ancient Bitcoiners, right? They were self-sovereign, all about freedom, but they somehow were able to coordinate together and fight off the Roman empires for many centuries. So that's kind of the story behind the Galoy name. Very, very similar to us, the Bitcoiner ethos. All right, let's get into code. So this is actually, I'm remoting into this box right here. I'm running Ubuntu on there. So let me get in here. Yeah, I switched to light mode. I'm usually not a light mode guy. I'm a dark mode guy. So this just makes it look a little bit better for the screens out there.
What do you use for the remote desktop?
I use a combination of VNC and Tailscale. Yep. So yeah, I can basically remote into it through my Tailscale IP, like a 100 IP address. And then I just VNC, and I just use remote desktop as my client on Mac. So yeah.
Sorry, jumping back just a little bit. With your Lightning node setup where you have an extra Lightning node, like what happens in a situation like what Brock did to LND, where like are both your Lightning nodes on the same version? You have to update them both?
Yeah, we just take one down, update it, take the other one down, update it. Just kind of in succession. Yeah. Yeah. Yeah, I was on call that week, so it was like a Sunday night at like 7. I was following Ben the Carman on Twitter, and I was like tweeting at him. I'm like, dude, like, are we gonna get all of our money stolen? What should I do? He's like, just wait for the update. So I believe Lalu pushed an update at like 9 p.m. on a Sunday, and we were able to get our node patched and everything out within an hour. Because really, it's one line of code I changed. I checked it into GitHub, and then our CI pipeline picked it all up and deployed it out to Kubernetes. So it was fairly seamless with our stack to do these emergency patches. But anyways, let's get into this. So right now I'm just using VS Code. And we actually have a repository out there called charts. So let me see. It's under GitHub. Our main Galoy repo is under Galoy Money. So if you want to see any of this code, we've got 65 repositories out there. But the one in particular that I'm going to use, usually when you're developing locally, you're going to pull down the Galoy repo, and that is our main GraphQL backend with all of our LND and Bitcoin, and we use Docker Compose to do our development locally. But I'm going to show you more of a production deployment of this. So that's actually in our charts repo. It stands for Helm charts. It's kind of like a package manager, kind of like NPM if you're a TypeScript developer, JavaScript. This charts thing helps you create Kubernetes packages that you can deploy. So this is the repository I'm working in today, is the charts repo. So let's jump into that. So once you clone the code, you're going to want to install a couple dependencies. And again, I'm not deploying this out to like a Google Cloud or AWS. I want to show that you can run it locally on your own machine. So I actually have this Intel NUC running here. And within this machine, you can basically run a virtual Kubernetes environment within Docker. So if I do a Docker PS, you should see I don't have anything up and running in Docker yet, no containers. So you just go to K3D is the tool that we use to virtualize it. That's just a download you can download. The second dependency you need to download is this tool called Terraform. And I wasn't familiar with Terraform until I started at Galoy, but it's a tool to help you deploy your code out to these clouds. It just kind of does diffs and change sets and does all these advanced features where you basically can do like a rolling update and have no downtime because you're running on a cluster of computers, and it just makes everything simple. And we'll go over that. It's a little complicated, but and the last tool you need to download is kubectl. I think a lot of people call it. I like to call it kubectl, but I think the official word is kubectl. It's kind of a goofy name. But this is the CLI tool for managing your Kubernetes cluster. Very similar to like a Docker CLI is the equivalent that you're probably used to. So after you download those dependencies, we've actually got this deb folder. And this deb folder means you can deploy it locally to like your own Kubernetes cluster. We have all the scripts and all the YAML files and all the Terraform files, all the nasty CI/CD stuff that developers don't usually want to deal with. We've written all of that for you, and we're going to go a little bit into how that works. So once you get in there, you can do a dir env allow. dir is a cool tool. It just sets your environment variables for you, so you don't have to manually have a .env file. Just sets all that up. So let's run that and make sure we've got all of our environment variables loaded up. So we've got environment variables. And I'm going to go into more details on what the heck Kubernetes is and what we're doing in a second here when some of this stuff is deploying. So the next thing, we have this command called create cluster. So this is actually going to create that Kubernetes cluster virtualized inside of Docker. So this is usually pretty quick, and I'll show you what it did in a second here. So K3D is the tool that allows this. It's by a company called Rancher. They make a lot of open source software. So now we successfully created a cluster. So if I do a Docker PS, you should see we have some stuff running. So this is essentially our entire Kubernetes environment running on this machine. And that's pretty powerful because typically you have to run this in a Google Cloud or AWS. This is kind of what runs the world. Like Twitter runs on a Kubernetes cluster. Pretty much every big company, I'm sure Facebook uses it. It's just how you run these big at-scale applications. But I kind of wanted to jump over to ChatGPT because I was trying to figure out how do you explain what Kubernetes is. So it kind of started with like, what is Kubernetes? Explain it to me like I'm 5. And it was kind of juvenile, like Kubernetes is like a boss of all the little helpers in your house. I'm like, all right, that's stupid. All right, let's go a little older. How do I explain it to me like I'm 10? And this is a little bit better. So yeah, Kubernetes is like a giant computer playground that helps you organize and run your games and applications. It can run many applications in this one thing. Just like how you have different games you like to play, there are different computer programs that people like to run. Kubernetes helps make sure each of the program gets the right resources like memory and processing power so it can all run properly. It also helps keeping track of all the different programs and make sure they work seamlessly, blah, 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 blah. And essentially, it's a high available clustered environment. So if you had an API, you're not going to install one instance of that API. You're going to install multiple instances. And if you have to update your code, Kubernetes handles taking one instance down, updating the code, taking the second instance down, so you never have downtime. So it's a highly available environment when you're running these production apps. All right. What's that? Yeah, I mean, for like our production application, we host on Google Cloud. So Google Cloud offers a Kubernetes offering. It's just a cluster of servers out there. Same thing with AWS. If Google Cloud goes down, yeah, we're screwed. Runs half the internet, AWS. You could essentially load balance between an AWS and a Google Cloud if you're that popular enough. But yeah, if Google Cloud goes down, yeah, your cluster's down. So we could redeploy to an AWS because we have all of our CI/CD pretty much automated. I mean, most companies have like a disaster recovery plan. All of our code is infrastructure as code, so we just run a couple commands and spin up a new cluster, and you're good. Yeah. So yeah, everything's automated. All of our configuration is automated. So yeah, we pretty much just run some commands and it deploys. Yeah, Ben?
How does Kubernetes compare to like Docker compose? Does it like sit almost on top of like you use a Docker compose like under the hood, or is it kind of...
Yeah, so the synergies between Docker and Kubernetes is you create a Docker file and you create basically your image, right? So we've got an image for the Galoy API, right? Just like they have images for Postgres and Mongo and all your dependencies. Same exact thing. Instead of deploying it to a single instance on your computer like Docker, you deploy it to this cluster called Kubernetes. So it's very similar in the sense in Docker, you typically use Docker compose YAML file to set up all your dependencies and how everything works. Same thing with Kubernetes, you have a YAML file where you describe what version of Linux you want, all your dependencies, all your environment variables and secrets, and then the Docker image that you want to deploy to this Kubernetes cluster thing.
More about like the infrastructure that you're actually running the Docker?
Yeah, Kubernetes is the infrastructure. Yeah. It's highly available load balance infrastructure. Yeah. Yeah, right here. It's running right next to me. Keeping my hands warm. Yeah, it's the same thing. It's the same infrastructure. So you can run Kubernetes on your own server. It's really a standard. It's a standard. So the history, there's actually a good documentary on the history of Kubernetes. It was actually Google that created it because they were so behind the cloud race with AWS. AWS had 90% market share back in 2013. Microsoft had barely any. Their cloud kind of sucked back then. But Google's like, how the heck are we going to catch up with AWS? Everyone's hosting on AWS. And they're like, oh, let's just create this open protocol, kind of like in Bitcoin. We have the Bitcoin protocol, Lightning protocol, other protocols. They created this Kubernetes thing. It's a protocol of how to run your application on a cloud, right? So you don't got to hit all these different APIs and do custom stuff for AWS. So really, this is infrastructure stuff. This is the stuff. A lot of the stuff I'm talking about is not like developer type stuff. It's more like infrastructure guy stuff. Yeah. And then it became part of this cloud native foundation. I don't know if it's under Linux, but yeah, it's this open protocol that everyone can take and run. So I run it on my machine. Google runs it in their cloud. AWS had to start running it in their cloud because their customers were demanding it. Azure cloud runs Kubernetes. So if you know how to write your infrastructure in Kubernetes, you can run it anywhere. Doesn't matter. Yeah. Yep. Yeah, we're going to run an entire deploy on, and it is the same exact way to deploy Kubernetes on this single box as to deploy to GCP or AWS. Same exact infrastructure as code. Terraform makes it easy to kind of the nuances between the clouds. Like each cloud has a different way to store secrets or environment variables. So this Terraform tool helps you navigate some of those nuances. What was, I don't understand the question. What was it? It can be any size, right? So if you're a small application, it could be a single instance, like 2 GB machine with 1 CPU in it. You know, if you're a huge company like Twitter, your Kubernetes cluster is probably hundreds of servers underneath it, right? Yeah, so it can scale up and down, and you can do it dynamically as well. Yeah. All right, so let me get into creating this. So right now, there's this tool called K9s, and this shows my entire environment right now, right? So if you're used to Docker Compose and using Docker Desktop, this is a similar view of like every application running within your cluster. So right now, we don't have much. We've got a DNS server, and then a couple other things. So this is just core stuff to Kubernetes.
Where do you get that tool?
K9s, it's just another download. You can just go to K9s, and then yeah, it's just it's Portainer essentially in a command line view. If you're familiar with that tool. All right, so we created our cluster. What's the next thing we have to do? So let's run make init, and I'll show you guys what that does. So let's go to our make file. If you're not familiar with make file, it's kind of like a package.json in like web development world. It's a way to run these scripts. So make init is actually this Terraform thing. This helps me deploy code to the Kubernetes cluster. And I'll show you what it actually did. Oops. So all that did was format my code to get ready to deploy. And I'll show you an example of these configuration YAML files in a second here. I want to kick off some of these deployments because it takes a couple minutes to go through. So the first thing I'm going to do is I'm going to deploy my services. So these are like your dependencies, like your databases, your stuff that these applications depend on. So let's do make deploy services. And this will really kick off a lot of things. So you'll see a lot of stuff start to kick off in my cluster here. Again, these are all the dependencies. Let me get rid of this to make it bigger. So you see that deploy is starting to kick off my dependencies. So we depend on this tool called Kafka, which if you're familiar with queues and pub/sub type architectures, it's just an open source tool that helps you do that. So let's see what else it's going to deploy. So now we're deploying certificate managers. So if you've ever deployed an application, you usually have SSL certificates to secure your application. Typically within the cluster, because it is distributed, you usually have TLS certs for each of the applications running. So LND has a TLS cert that helps secure it. LND talks to Bitcoin D. Bitcoin D has a TLS cert. So we've got a certificate manager within here. The next thing that our dependencies deploy is this ingress. So if you're familiar with deploying code, you typically have to have an ingress. This is your public IP. This is the public endpoint that everyone hits, and then it goes inside your Kubernetes cluster, which is private. That's firewalled off. You don't want anybody in your Kubernetes cluster. If somebody's in there, they're a hacker trying to steal your stuff. Usually that's just for the system administrators. So our ingress helps expose some of our ports. All right, what else are we installing? Yeah, essentially, yeah. We're using Nginx as a reverse proxy for our ingress, and we'll go into that in a second here. Another thing you need when you kind of deploy these real enterprise apps to production is some way to do tracing. So that's almost like if you're a web developer, you probably have a bunch of console.logs. That's kind of how most people start. But it's kind of like logging like on steroids, right? You have an end-to-end view of your application from when somebody hits it. They do a couple HTTP requests. They might get data back, and then maybe they get a bug, like 3 requests in. Tracing gives you an end-to-end view of all of that stuff, and it records all of it so you can go back and troubleshoot problems. So we use a tool called Open Telemetry to do that. It's kind of an industry standard nowadays. And I think that is probably all of our dependencies. Let's see. All right, so the next thing we're going to do is make deploy. And this is going to deploy our entire stack, the Galoy API, the web wallets, Ride the Lightning, LND, Bitcoin, everything. So this one command, I'll go into the configurations files behind this, but this takes about 5 or 10 minutes to deploy. So let me kick that off. 1 second, Topher. And then we'll show you everything's going to light up here. So boom, we're getting Bitcoin D installed there. That's one of our dependencies. And once Bitcoin D gets installed, LND gets installed because LND depends on Bitcoin D. Once LND gets installed, our Galoy API gets installed because that depends on LND. So you can kind of see this dependency tree starting to form here. And I'll show you a couple configuration files in a second. Topher, you had a question?
Yeah, so it seems like there's 2 services trying to access port 80 at the same time. So when I run deploy services.
Yeah, don't follow along because there's some bugs within that repo that I have like a custom thing I got to check in. So yeah, you're gonna run into bugs. You're gonna run into bugs. You're way ahead of the game, but we'll get it running in your machine later today if you're interested. But yeah, there's a few things that aren't configured because we have to tweak the configuration a little bit for this K3D environment.
All right. Can you show the dependencies that you enforce during deployment so that A component A deploys before B?
Yeah, I'll show that in a second here. So you see we're getting LND up and running. We've got LND's Postgres server. All right, so let's since that's all good and starting, it's going to take a couple more minutes. We can dig into some of the configuration files. I'm trying to think of a good example of a file I could pull up. And I'm no expert at any of this stuff. This stuff was already set up before I came here. I just dabble in Kubernetes. I just thought it was an interesting topic. Just for the previous workshops we had, just kind of an evolution of how, when you write code, how does it get to like a production state? So within our folder structure here, let me kind of go through that, the folder structure. We basically have charts, CI, and dev. Dev is essentially where all the configuration lives for running it locally in like this local K3D environment. Everything under charts is kind of the base configuration where you can use it to deploy to like a Google Cloud or a AWS. There's some customizations you have to do if you switch between the cloud providers, but for the most part, this is all the base configuration. So if I were to go into let's look at the configuration for like our Bitcoin setup. We've got these YAML files here, which kind of is where you set everything. And if you're familiar with Docker Compose, this is the same theory. This is where you put all your configurations. A lot of the stuff is dynamic. So you can see for Bitcoin, we're running our network as regtest because we're running this locally. Other values could be testnet or signet or mainnet. We're running it on this RPC port, 18443. If you wanted to run it on a different port, this is where you'd put that configuration. And to show you like the dependency, so I believe most of our dependencies are in these Terraform files. So if I go to Bitcoin, and I'm not very well versed in Terraform. It's made by this company called HashiCorp. But their whole big thing is just dependency management and deployment, right? So if you change like the Bitcoin port, the RPC port from like 18443 to 18444, you would change that in here, and then Terraform would basically do like a diff. It would see, oh, you changed this one thing. If you want to redeploy your application, we don't have to install the whole thing, LND and this. We're just going to redeploy one thing in Bitcoin, and that it just handles the dependency with like one line of code. And I'll show you that later. But let me see. There should be a depends on. So the depends on keyword is where you would get those dependencies. So before this Bitcoin thing can be deployed, we have to deploy this thing called Kubernetes secret. So it needs to have a secret to deploy. So the same thing would be if it depends on, well, Bitcoin doesn't depend on anything. If it was LND and it depended on Bitcoin, you'd essentially have the depends on clause here. So that's kind of how that works. And I'm not going to go deep dive into Terraform because I barely know how it works. I just know these YAML files and they get smushed together and you can deploy stuff. I'm still new to a lot of this, but let's dig into what is going on here. So you see this namespace thing, right? So typically when you deploy an application, you want to break it up into different namespaces based on how things are related. So you can see we have this Bitcoin namespace here. Obviously, that's where we're throwing LND stuff. We've got Loop out there, Lightning Labs Loop for liquidity management, doing submarine swaps when you have to swap between on-chain and off-chain. We've got Ride the Lightning there. If you've used that on like your Umbrel node, that helps you, again, manage liquidity and do transactions. So the next namespace we have is this Galoy. This is where all of our custom code lives. We've got our API, so this is where all the code lives with the GraphQL API. We've got this Kratos thing. This is like our authentication and identity management system. I'm not going to go super deep into that. We've got Mongo database is where we store a lot of our stuff. We've got Postgres. We've got this Galoy price thing. So we actually do price aggregation feed. So we use several different exchanges to aggregate a price of Bitcoin. So that's what this service does. I mean, you can kind of see once you start getting into these larger applications, I'm sure you've heard the buzzword microservices before. If you use Kubernetes, it really allows you to build like these microservices. You might have 10 services, and then they might communicate via gRPC. And really, you can start breaking different independent components apart. Like we could have stuck that price feed within our Galoy API, but a lot of times we get a bad feed from where we're getting it. Maybe Kraken goes down, or they become just giving us a bad feed, and we want to start using a different exchange. It's independent of the API. We wouldn't have to take the API down if we wanted to update an exchange that we're pulling a price feed from. So it's pretty smart to break all these namespaces up. Same thing, you can see we've got this ingress stuff. This is where all the networking stuff happens down here, and then the Kafka and all that stuff. So that's kind of our stack in a nutshell. So let's actually start seeing how you would actually hit our API. So at this point, everything is within this Kubernetes environment. How do I go to a URL and hit the GraphQL API? Let's go over doing that now in a second here. Oh, it just deployed. Cool. So you can see we just literally deployed all that stuff, 64 things with like a click of a button and a bunch of YAML and Terraform files. I would go into some of the details in those, but it's not super interesting. It's just like another language you got to learn. Like you learned JavaScript, you got into Docker, you had to learn how to do a Docker file. Then you advanced into Docker Compose, you had to learn YAML file. It's just an evolution of that. Once you start deploying out to these clouds, you just have to learn slightly different way to configure that. So let's start playing with this stuff. What's the first thing we should do? Should we go to the Bitcoin node and mine some blocks? Yeah, let's do that. Well, this is just on one machine, so it's one node. Yeah, so this would be equivalent to like the cheap model, like you're running one node. It's not highly available. If I unplug the button, everything goes down. Typically, if you run it in a cloud, you're going to have a cluster, right? You're going to have 3 computers, probably minimum. So if one computer goes down, one VM goes down, you've got your other 2. So right now, it's not a high available mode because I'm running it on this little computer next to me. Why am I running on this computer? Oh, because it's cool. Like, we're Bitcoiners, man. We can run our own bank in your closet. Yeah, like we run our own Raspberry Pis in our closet. We can run our own banks in our closet if you wanted to. Yeah. Well, I'm remoted in just because I like to do it that way because I can switch between. But yeah. Anyways, yeah, let's start playing around. So this K9s tool is cool because it makes it very easy to remote into these machines. So typically you'd have to like SSH into a machine or do like Docker exec and all that crazy stuff. But with this K9 tool, I can basically just hit S for shell. So let's go to our Bitcoin node and just hit S. And I'm in Bitcoin. And boom, I'm in a shell for Bitcoin. So you can kind of see our data structure. So the first thing you do when you get into a Bitcoin node, if you've ever ran one yourself, is you got to create a wallet. So let's create a wallet. I've got a cheat sheet for this because I always forget the commands. They used to automatically create a default wallet for you in Bitcoin D, but they don't do that anymore. I don't know why. You've ran into this before, right? When you go into Bitcoin D, they don't create a wallet for you anymore. Yeah, it's deprecated. All right, so I've got a command for that. So yeah, let's create a wallet called testnet with the Bitcoin CLI. And in a real environment, you can pre-configure all this stuff. I just wanted to demonstrate how you can play around with a lot of these things that are running in Kubernetes, the same way you would do if it's running on your own machine. So let's create a test wallet. Cool. The first thing we want to do is probably get some info about our node just to make sure it's up and running. Cool, we're up and running. I'm running in reg test, so I basically have to mine the blocks manually. So if you ever ran a reg test node, you might do a transaction like, why the hell is it not mining? Like the first time I did it. And a lot of people run Polar, where you have to click the mine button. So yeah, it doesn't automatically mine because we're not hooked up to a network in reg test. We're just mining on our own machine. So the first thing you typically do in Bitcoin D is you have to mine a block. So I'm going to use this little helper here to mine a block. So essentially what I did is I used the Bitcoin CLI to mine 7 blocks. And these are the outputs of that. So I just mined 7 blocks. Cool. Who got that money? So it was this node. So if we want the money to start going into your own wallet, you might want to use a tool like Ride the Lightning to get better visibility into what your node's doing. So we installed that. So let's actually exit out of here, and let's get some better visualizations on what the heck's going on in our Bitcoin network. So we've got down here, Ride the Lightning. Cool. How do we get into this Ride the Lightning node? So typically on your Umbrel node, you just click a user interface, and boom, you're in your Ride the Lightning. Within here, it's not as easy. We actually have to port forward so we can access it on our host machine. So there's a easy button. If I hit Shift F, I can actually do the port forward right here. So we're going to port forward on, we're not going to use 3000 because I'm using that for something else. I'm going to change the port to 3005. And if I hit OK, we've got the port forward activated. So now I go to my host machine, and I can actually open up localhost 3000, and we'll see Ride the Lightning. So let's go here, and magic happens. Yay, we're on Ride the Lightning. So now what do we need? Oh, crap. I don't know what the password is because all this stuff was auto-generated by those config files. How do I get that?
Sorry,
Yeah.
What exactly is Ride the Lightning?
Ride the Lightning is a visual tool for helping you manage your Bitcoin and Lightning node. So it'll show you your wallets. It'll allow you to do a send and receive. You can do UTXO consolidations. I'll demo it in a second here. So now we're in the problem of how do we get a password to get into Ride the Lightning. If you're familiar with Umbrel, you usually just go to a screen and it tells you the password. Let me show you how you do that in this environment. So let's go back to our Kubernetes cluster. And I'm going to run another tool called Portainer, which a lot of you, I know Topher's familiar with that tool. He manages his own Docker environment with that. But let's install it. Let me go back to my notes cheat sheet. We'll introduce a new tool called Helm. So if you want to install Portainer, within a Kubernetes environment, we use a tool called Helm. it's equivalent to like npm or node package manager if you're a JavaScript developer. It's just a repository of where people have these container images. So let me run portainer. And it's super easy, like a one-liner. Helm install portainer with a few configurations. So the next thing is I need to get a password and open it. So I've got just these cheat sheets. I'm not going to go through the details. But boom, I run one more command, magic happens. Give it a second. It should go through. Give it a second. Live demo. Come on, there it goes. All right. So now with those two simple commands, I've got a visual representation of my entire Kubernetes cluster. So let me log in. This is like a system administrator type view, if you want to think of it that way. So yeah, we're in portainer. Let's see what the heck is running inside this cluster. This stands for Kubernetes cluster. And let's, this is very similar to that K9's view. You can see my entire environment by namespace. So Ride the Lightning is in the Bitcoin namespace, right? So let's go to Galoy dev Bitcoin. And let's search for Ride the Lightning. Where is Ride the Lightning? Oh, here it is. Cool. Here's Ride the Lightning. Let's drill into that. All right, how the heck do I get my password? I don't know how to log into Ride the Lightning. How do I do this? So typically, you're going to want to find your secret. And an easier view is to actually just go into config maps and secrets. So let me say, all right, I know there's a Ride the Lightning password stored somewhere in here. There it is, Ride the Lightning password. Oh, cool. There it is. So yeah, equivalent to like an umbrella, you just go to a website and get your password. Similar thing here, it's just stored in a secret store. Kubernetes has a secret store that can store all this crap for you.
Did you run portainer? Like, when did you run that? Was that right? Or was that just going on the whole time?
I just installed it like 2 seconds ago. Yeah, Helm install portainer is essentially the command.
You can install it with Docker too.
Yeah. Oh, wow, it switched to dark mode. Cool. All right, so now you can see our node. We've got our node alias. It tells you we're running LND 15 under the covers. We're connected to Bitcoin Reg test. Awesome, but we're poor. We have no money. Shit. Let's get some money. Let's get some money. So, all right, let's mine some blocks, and then we'll give the miner reward to this guy. So let's go to our on-chain wallet here. What do we want? We want taproot address, or we want a Bec32 Topher? What do we want? Taproot? Hell yeah. Taproot all the way. All right, so we grab a taproot address per reg test. All right, so let's go. Let's pretend like we're a miner now, and we're mining a block to this address. So let's go back to our K9's environment, and let's remote into our Bitcoin node. All right, where's Bitcoin? Remoted into our Bitcoin node. We'll hit S to enter the shell. All right, let's mine a block to this address. I always forget the command to do that, so I got to go to my cheat sheet. Cheat sheet. I'm going to mine 111 blocks because I'm crazy, because I want to be extremely filthy rich. Yeah, so let's mine 111 blocks. So I'm going to get, I think, a 50 Bitcoin block reward was the original, right? So I'm going to get 50 times 111 Bitcoin. I'm going to be the richest guy in the world.
It depends. Is it a brand new chain?
Yeah, it's a brand new chain.
And,
50. Is it 50?
It takes 100 blocks to approve.
Okay, so we're going to do 111 blocks.
Yeah. So you'll get 11.
All right, so let's get it. All right, so we just mined 111 blocks. Let's go back to Ride the Lightning and see if we're filthy rich. It might be pending in UTXOs. Might have to hit refresh. There we go. Oh, we got 12 UTXOs. Hell yeah, we're rich. All right, so we've got a $60 billion Satoshi. What is it in Bitcoin? We got 600 Bitcoin. We're a whale. This is how Satoshi felt in 2010 or 11 probably. All right, cool.
When is the Lightning wallet created? What part of the deployment process did the Lightning wallet create?
That was in the make deploy. It deployed the YAML and Terraform files for LND, and it did that after Bitcoin was up. Yeah, so that was all within this repository. That stuff's already configured for you.
The reason I'm asking is you have to make a Bitcoin wallet manually, right? But the Lightning wallet got created by money.
Yeah, so I can go into our Lightning node if you want to see that. It's a little bit hard to demo a Lightning in RegTest when we do this, just because I'm the only one in the network. I don't have any friends to open a channel with. So I'm going to do probably more on-chain transactions. But I can show you what our Lightning node looks like. If I exit out of our Bitcoin node, let me get out of here, make this bigger. So we do have a Lightning node here. LND is what we're running. So if I shell into that, let me go into just ClearNet. So I can run like the LN CLI. I'm on the RegTest network. I don't know, get info, is that the command? Yeah, so there's our Lightning wallet. It was essentially automatically created as part of our deployment scripts. It created all that for us. So yeah, that's fun. Oh yeah, let's put some money into this wallet. What is the command? LNCLI new address maybe? New address. So let's get a new Bitcoin address. It's probably gonna ask me, do you want a Taproot? Yeah, I want to pay to Taproot because that's what all the cool kids are using. Boom. So I've got a Bitcoin address. All right, let's mine a block to our LND node. Let's make ourselves filthy rich. Let me just open a new instance of this K9 so I don't got to switch back and forth. Let's go to K9s. All right, let's go to our Bitcoin node and mine a block and give it to our Lightning wallet. Let's shell into that. Bitcoin D. What is the command? I'm going to memorize it this time. Bitcoin CLI generate to address?
Yeah, generate to address. The number of the address. We have to do more than 100.
112. We're going to be rich. All right, so boom. All right, now let's go back to our Lightning node and let's see, what is it, wallet balance? Is that the command? Boom, we're rich. So I should have showed that before because before it was 0. We were poor, now we're rich. All right, cool. So this is like all the back-end magic stuff.
Sorry, just one question. So
Yeah.
go back for 5 minutes. You made a Taproot address, right?
Mm-hmm.
You actually made a Taproot address. What was that address?
So you're talking about within Ride the Lightning?
Yeah. What was that used for?
So when you create addresses in a Lightning node, it just lets the node track the balances of those addresses. So when you send money to them on chain, it'll see them.
Oh,
So,
Yeah, I'm trying to think. Which is this the same wallet? Yeah, so I think this is the same wallet. I believe I'd have to look at the config. I think this Ride the Lightning is connected to our LND1. Yeah, LND. Does it show you like the RPC port? Oh, here, node config. We're connected to, I don't know, something. Yeah, but this is the same node. The Ride the Lightning is just a web interface on top of our Lightning node that we just did the CLI stuff with. So
if we're on chain.
so can you mind just repeating what you said? Not about it, but
Oh yeah, so Lightning nodes have like they have an on-chain portion and then they have the portion with the Lightning channel. And so you need to put funds in your Lightning node before you can put them in a channel. So you typically LND or Core Lightning, they'll have their own wallet that will manage on-chain funds. So we created an address in the Lightning wallet so that the Lightning wallet knows to track that address for any payments.
Yeah.
receiving on-chain.
And I'm just doing on-chain Bitcoin stuff because it's hard in this local environment to open channels up. We could script that out, but it's just not set up yet. So let me start showing you some, now that we have the core infrastructure, the Bitcoin node and the Lightning nodes up and running, we have a wallet. Let me show you further up the stack, all the stuff that Galoy layered on top of it, like our GraphQL API. I guess we'll do a quick 101 on GraphQL. Does anyone know GraphQL here? Am I the only guy? Oh man, one guy kinda? Okay. Man, Bitcoiners don't know GraphQL, it's crazy. You're all gonna know it in a couple minutes here and you're gonna love it.
JSON, mutation.
Yeah, I mean, it's just like you're writing code. It's instead of doing like REST, where everything's a get, put, post, or delete, and then you've got these long query strings, and it's request response. It's more like you're just still in JavaScript, just writing code, and like magic happens where you get data back from a server. It's like a simple way to describe GraphQL, but I'll show it to you in a second here. All right, so what do we have to do to get our API exposed so we can get it. We probably got to forward some ports. So let's go back to our K9s. Let's get out of our Lightning node. Let me actually just kill this. So I just have one instance running. All right, we're back to our first state. All right, so now we're heading further up the stack. So everything's in the Galoy dev namespace, and we have this API thing here. Except we're not going to port forward this API because we put a reverse proxy in front of it. You don't want to probably just expose your API running like an Express server because there's not a lot of rate limiting and like all this stuff running in production. You want to make sure you probably put a load balancer or reverse proxy in front of it. This is kind of like our project of rate limiting. So typically we rate limit 2 requests per second just so we don't get beat up. Like I'm sure Will's not doing this on his Nostr relay. Maybe he is, I don't know. But anyways, let's go to our ingress and actually let's port forward our API through that guy. So it's right here. Typically I could do a Control F and port forward here, but I'm not going to do it that way because I want to bind to the 0.0.0, the everything address, just to make it easier. So let me do it a different way. Let me get the command for that. I always forget how to port forward. This is similar in Docker. You can port forward stuff so you can access the data on your own machine. Let's go into dev. Let me go to my cheat sheet here. We already did portainer ingress. All right, cool. Let's port forward our ingress. I'll go through the details of this in a second. I just want to get everything up and running. So this first command here, I'm port forwarding I'm binding to all my interfaces, and then my network interfaces on this box just to make it easier to deal with. I'm going to port forward my ingress controller. Whatever's running on 443 in Kubernetes, which is my API, I'm going to port forward to 8080 running on my local machine here. So I just did that. Same thing, I want to port forward my web wallet. We actually have a web wallet where we can actually, similar to Ride the Lightning, get a visual representation of what's going on. So let me port forward also our web wallet. And that runs on port 3000. So let's port forward that. Oh, shit. Wrong name. All right, so this is misnamed because this is a previous deployment I had. So at this point, I need to find the pod named web wallet, and they usually append numbers to the end of it to make it unique. So if I want to port forward the web wallet, I need to search for it. And this lives within a different namespace. We put this in the Galoy dev add-ons just because this is stuff that not everyone runs, like the web wallet or the mobile wallet. So I want to port forward this mobile wallet, web wallet. So let me grab the name of this thing, and let me paste it here. And let's go. All right, so we're port forwarding 3000 and 8080. So I can go to a normal web browser and start looking at this stuff. Let's go to our GraphQL API first, and I'll show you guys how that works. All right, this is typical. If you get this 401 error, it probably means there's a cookie that didn't get deleted from the last time I was playing around. So you just can clear, you can see there's these cookies just left over. So this is just nuances of demonstrating locally.
Is the port forwarding working from a non-encrypted port to an encrypted port because it's skeletal?
Yeah. You'd want to use SSL HTTPS for everything in like production. Usually your ingress will handle that. We're just doing everything in development, so I'm just using just clear text HTTP. All right, so we're connected. So this is a thing called Playground. So if you're not familiar with GraphQL, this is a good starting point because it gives you a lot of information here. So GraphQL is strongly typed. So you inherently get your schema. So you can actually go to the schema tag and see what our entire schema looks like within our thing. You can see we've got an account with like a wallet. So every user has a wallet. They have limits of how much they can transact. They have a list of all the transaction they've done within their wallet. Another type is wallet. Wallets have IDs, they have balances, how much Bitcoin is in my Bitcoin wallet. So this is kind of the nice thing about GraphQL is you get this strongly enforced schema. So if you're into a strongly typed language like TypeScript, it makes development a lot easier. And they've got this doc sessions too. So it shows you all the queries you can run. So to back up, in GraphQL, you can do two things. You can do queries and mutations. So if I were to equate that to what normal people are used to, like get would be a query. Post would be a mutation. Delete in the REST world would also be mutation. Patch, when you update something in REST, that's also mutation. So everything's either read or write, mutation or query. So that's the two main high-level things of GraphQL. That's all you need to know, really. That's the GraphQL in a nutshell. It's JSON and queries and mutations. Super easy. So you can see all of the different queries you can run. The most interesting query to run is the me query. So typically in GraphQL, you get your data. So typically you start with a me query, right? OK, what can I get? I can get my phone number. I can get my user ID. I can get all this different information. All right, screw it. Let's just start querying our thing. So before I can start querying the database, I have to authenticate. So authenticating is a mutation. So let's type in mutation. And what do we want to do? You get IntelliSense because everything's strongly typed. So we want to log in. So I can just start typing login. Oh, user login. That's probably what I do. And it's kind of like JavaScript, so it's like a function. So then you can say, all right, what is the inputs I want to put into this get login? Probably like a username and password, right? Something like that. A phone. So right now our system is set up to use phone numbers as login. And I'm running in this development local environment. So we mocked a bunch of phone numbers. So we got a bunch of Twilio codes and phone numbers just kind of mocked in our database. So I'm going to input these fake phone numbers and this fake code. We just have like a fake 321321. And we're using a phone number from like I was saying, this is mocked. So you can actually grab this phone number from our configuration file. So if I go under the dev area, there should be a configuration file under Galoy for reg test. So this is our mock. This is all of our configuration. So this is like in Docker Compose. This is kind of like your YAML file where you configure your application. So our Galoy API, the thing I just showed you, our GraphQL API, runs on the network reg test. Here's the actual Docker image. I'm using a custom image I made. And this is probably why it doesn't work on your machine. You're not using my custom Docker image. And this is the same as in Docker, right? It's the same image that you would run in Docker is what I'm running in Kubernetes. So there's no difference there. And within our application, we have these things called test accounts. And this is the mocked phone number I want to steal to be able to log in. So let me paste that into our login function. And so that's only half the battle. Now that's what the function I want to run. The next part of this GraphQL syntax is the data I want returned. So I want probably any errors. If there's any errors, I want the error message. I also want to get the auth token, the thing that allows me to authenticate. So let me get that. And that's essentially a typical mutation in GraphQL, is you've got the function you want to call with the inputs, and then you've got the data you want returned in the second section. I could like make it a little more separate to show it's kind of like two different pieces, but all right, drum roll. Let's see if this actually runs. And boom, I got the auth token. So basically what happened there is we have an authentication thing. We use this thing called Kratos. It's an open source identity management product, and it gave me this auth token. So the next thing you want to do with this auth token is let's do a query now. So I probably want to query me. You don't have to write the word query. You noticed before I wrote mutation. You could write query if you wanted to, but I don't ever do it. I just go right into it. So I want to probably get my ID and my phone number. Queries are a lot easier because you don't have to do like the input part of the function. You just what I want back. I want my phone number. I want my ID. If you hit control space, it gives you IntelliSense. What else do I want? I probably want my default account. What does the default account give us? And if you don't know how to use GraphQL, you just kind of go down and you hit control space like you're writing code. Okay, what's in my default account? Oh, I have wallets. Cool. I want to see all my wallets. Okay, within my wallets, what do I want? I probably want the balance of my wallet. That'll be cool. What else do I want? Probably if I have any pending, if I have some UTXOs that haven't been, that are just pending in the mempool. Yeah, let's get those. Let's grab the ID of this wallet. Yeah, that's probably good enough. So right now it's going to fail because I'm not authenticated. So let me just do a failure. Not authenticated. So this is very typical. You just go down here to this HTTP header section. I can drag that up. And this is your basic authorization bearer token that if you're a web developer, you've probably done this a million times. So now that will authenticate me, and boom, I got my data. Damn, I'm poor. Let's get money. So this is where I could do a mutation where I could get a taproot address, kind of what we were demoing earlier within the Bitcoin and LND stuff. But let's actually use one of our applications. Let's use one of the Galoy's web wallet to actually generate this address. So if you remember earlier, we basically port forwarded 3000. So this is actually where our web wallet's running. And ignore this next part because it's a hack I had to do, and I don't want to explain it because it's too hard to explain, but I'm doing a reverse proxy to rewrite some CORS headers to make sure I can access this. Yeah, just believe me. Topher knows what I'm talking about. All right, so now we should be able to go to our web browser and go to that localhost 4000 because I'm using that proxy to fix some weird nuances stuff. And you should see, fancy, boom, here's our web wallet. All right, cool. We've got a Pleb wallet here. So let's, well, before we receive Bitcoin, we have to log in. I've been having issues with this, so cross your fingers that this actually works. So let me grab that same phone number that we were mocking before. That's not the phone number. Where'd it go? Phone number. Control C. I'm used to doing it the Mac way where it's Command C, but in Linux it's Control C. I know, no, Command C. I'm a Command C Maxi. All right, Control V. All right, so there's that. Typically in a production environment, you'd get the little slider thing where you got to verify your identity. But let me, and this is typically in our production app where you'd get a Twilio code on your phone would buzz, bzz, and then you'd get like a 6-digit code. But for us, we're just mocking this, so it should be that. All right, cool. So now we want to get a received Bitcoin address because we're poor, because we got nothing. So let's hope this works. Yes. All right, so this is a Lightning address. Like I said earlier, we didn't set up Lightning channels, so let me grab a, one second. Let me grab a Bitcoin. Oh, damn it, it broke. All right, this is what was happening earlier. Something fell down. It was my proxy. Why did it fall down? Oh, no. All right, let's try that one more time. I might just give up on this demo because I was having issues with cores earlier. You had a question? Yeah, so there's one guy on our team who works on like the Raspberry Blitz project too. OpenNom's his name. He's trying to do that. Our environment's a little bit beefier because we have all these telemetry and monitoring tools that I might get into later. So it's a little bit harder to run like a Kubernetes native environment on like a Raspberry Pi. You probably want more like an Intel NUC. And I think the Start 9 project is getting away from Raspberry Pis. I believe they're actually using an Intel NUC, like a $500 computer. I mean, if you're going to run it for yourself and your 10 friends, this is overkill. This is meant to be ran for tens of thousands or hundreds of thousands of users. This is meant to be like you're hosting a Lightning wallet for a community, bank, or like a country, like the country of El Salvador. This is meant to have a team of like DevOps engineers and like, yeah, this is not meant for just a single developer dude running it at home. You can do it, but I mean, there's a lot, there's a lot to it. I'm not a DevOps guy. I just hack this stuff because I find it kind of interesting. I'm more of a full stack developer. But yeah, if you're going to run this at home, you're probably just going to use Umbrel. If you're going to run it for like a simple application, or even maybe hundreds or thousands of users, like I believe Bitcoin Company runs their backend on Voltage. So that would be an option. This is like if you're going to go big, go home. So. Yeah. Yeah, so that's the concept of replicas. Let me show you that. And that's high availability. So if we were actually running this in a real Kubernetes cluster with multiple underlying machines, you would have multiple replicas for each of your individual pods. So let me show you what that looks like for our API. We actually have 2 pods running our API. So if you see this right here, we have 2 APIs. So we're load balanced, round robin. So the first user that hits our application goes to this first API that ends in 65x21. The second user that hits it hits that second node because it's load balanced. And if one of them goes down, your application's still up. So that's the high availability feature. And that's a configuration in the YAML file. It's just replicas. You do 2 replicas if you want high availability. If you have 1 million people hitting your app like Twitter, they probably have 500 or 1,000 replicas for like, I don't know, whatever their news feed or whatever their feature is that they built out. Yeah, you can automate it. There's tools for automating scaling up your pods. We don't use it yet just because we don't have that much load. At that point, you're probably a company like Twitter, and you probably have hundreds of engineers working on this DevOps infrastructure if you want to dynamically scale up and scale down. But yeah, that's a super advanced thing you can do within Kubernetes. It's more like a Kubernetes cluster. It could be 1 million servers running underneath. It abstracts that complexity from you, right? Yeah, I have a Kubernetes cluster running on 1 physical machine. Yep. Yeah. Yep, exactly. Yep. So it's almost you can almost map like 1 application to 1 pod. 1 application like ride the Lightning, you can have 3 pods running underneath it for high availability. But yeah, a pod is like an application essentially, yeah. Exactly, yep. Yeah, I got like 60 things running in here. And I can put more in here, man, if I want to install any database like Postgres, Redis. I have almost all the databases running. I have Postgres, I have Mongo, I have Redis. It just depends. Like out of the box, L&D runs with Postgres is like one of their databases if you don't use their embedded one. Our application, we just use MongoDB. It just depends on what the application requires or what your personal preference is. No, GraphQL is not a database. It's just a wire protocol. Yeah, it fetches from our Mongo database. You basically write a resolver. So you hit the GraphQL endpoint for like user login, and we have a resolver, and that tells you that's open. Your code, your logic tells it what to do. Go to Postgres, go to Mongo. So yeah. Yeah, it's all your logic. Just like a REST API, it doesn't know what database or how to do it. You got to write all the logic to how to fetch it. There's tools like dgraph I've been kind of looking into, like how do you do a GraphQL, but without having to write all the backend code. So look into dgraph if you're kind of interested in that. It kind of turns GraphQL into a database, and they do a lot of magic behind it to make it just map to what your database would look like. But yeah.
So the GraphQL schema you showed us earlier, right?
Yeah.
That defines the operations or the operations that are permitted to be performed from your lightning wallet. Is that correct?
This is a GraphQL API written on top of our Galoy code, and our Galoy backend uses LND to actually do the lightning code. So yeah.
The GraphQL schema that you showed earlier.
Yeah, let me pull that up.
That schema is the one that defines the boundaries and the restrictions around the operations you can perform using the lightning wallet.
Yeah. So if you can do, like, for instance, let's look at all the queries you can do with the Lightning Wallet. We can do a Lightning invoice payment status. Is it paid or not? You can look at on-chain fees. There's ways to create invoices from our API. That would be under a mutation because you're creating something. So we can even create a Lightning invoice on behalf of somebody else. We actually have a company in El Salvador called Tianki. They actually use this feature. It's like a public API. If you want just an invoice created to go to Topher, you could hit our API and you get a LN, CR invoice. So yeah, that's part of our API is creating Lightning invoices.
When you're doing development work, you're not like running Kubernetes, like you're not doing any of this on like a day-to-day basis.
No. Like my development environment, I think it's up and running right now. It's just in Docker. It's just a Docker Compose. If I pull up this is like my day-to-day development environment. It's the same stuff. I'm running L&D. I'm running all of our stuff. I'm not running our API because that's running locally. Does that make sense? Yeah.
Your Bitcoin Beach GraphQL API is just open to anybody. Anybody can hit that.
We don't have like a open API yet. It's kind of on the roadmap. We have there's a hackway. We're going to create a hackathon environment probably. So if you want to test our API and play with it. Yeah, I mean it's some of our endpoints are public. If you know how to get to like a GraphQL schema. Yeah, it's not like a super official reported thing. Like we don't have good documentation on it yet, but it's in the works. Like Strike has an official API where you get a developer API key and you can use it. We don't have like that yet. It's on the roadmap, but.
So you're planning to open up like the map would be cool. That's why.
Yeah, because I think all the integrations would be cool. Just like, hey, you want to build an integration within this, or just use us to host your Lightning, because it's not easy to run your own Lightning node for thousands of users. That's why most people just go to OpenNode, and then it's just you outsource all of it. This is kind of like a happy medium of like you can run it yourself if you have enough technical ability. But yeah, eventually we would like to have like a GraphQL API for Lightning, like be that service we can provide to people. Yeah.
How do you, from a release management perspective, right, you have this lot, and then you have the GraphQL interface back in the UI, right? So how do you think the changes? How do you make sure that you make the changes to the UI also, keep them in sync for release management?
Oh yeah, we use a database behind the covers. So basically the GraphQL API hits our backend server. We have our business logic, and we write to Mongo database. And we also have a gRPC persisted connection to Lightning, our LND node. So if LND tells us this invoice was paid, we pick that up and then we write it to like our database. So there's a whole backend database and gRPC infrastructure. Oh yeah. So GraphQL uses HTTP post. So every GraphQL mutation or query is just an HTTP post, and then. Yeah. I don't have it pulled up, but we have a mobile wallet, like our Bitcoin Beach wallet. I could probably pull it out on my phone, show you. But yeah, I didn't want to get too much into the front end stuff with this workshop just because I know like Austin did a lot of front end stuff. I wanted to stay pretty much back end. But yeah, we've got typical mobile apps, and like I've got the Bitcoin Beach app installed on my phone, a very typical wallet. I've got $20 in there. You can see all my transactions are buying stuff from the refrigerator here. But yeah, we've got a wallet, typical wallet. I don't know. Are we going to get it working? Let me see what was on my list. I've got. Yeah. I mean, that was kind of the idea. Like this is for the plebs, man. Whatever you guys want to go through. We've been doing this for an hour and a half. I don't know if people are bored or tired. That was almost my last demo. Like, yeah, I don't know. I don't know if I want to beat up the web wallet because it's kind of broken on my machine. Let's give it one more try. This mysterious proxy thing. Let's see if it works. I've actually got another way to do it. Let's try it the other way. It's a cheat because I have this CORS proxy thing. And if I go here, oh, whoops, 3,000. I think it all fell down. Let me look at my Kubernetes cluster. Gotta call the server admin. The server's down. What the hell is going on? Let me go back in. So another cool thing about this K9s tool is you can do like shift : and you get kind of this command. So if I type in PF, I can see where all the ports are forwarding and nothing is forwarding. So something broke. So then if I go back, I can type namespaces, and that'll pull up.
So
back.
can you like restart services like you would like in hypervisor?
Oh, yeah. Let's go into, yeah. Oh, yeah, you used to be an IT guy, so you're familiar with some of this stuff. So how deep did you get into like VMs and
Restart
hypervisor?
services always works.
Okay. So Carr is saying he used to be like an IT guy where something would break and then he just restart like a VM or something. So let's actually kill this. So let's say something bad happens, and this right now I have a replica set to 2 for our API. Let's kill one of them. Let's see what happens. I believe Control D will delete it. Let's just straight up delete this pod, be malicious. Okay, Control D. So boom, it turns red. So we still have one API up and running, and it just restarted itself. It self-healed. If I go to our API, let me see if I can get there quick enough. Oops, wrong button. I should be able to hit refresh, and it should all still be there. So we didn't have any downtime, right? And if I go back to our Kubernetes environment, you can see it self-healed. This new pod right here, if I scroll over, it's only 27 seconds old. This other one's been up for 40 minutes. So yeah, there's no downtime in Kubernetes. That's the beauty of it. And if I were to deploy, let's say I were to deploy an update to our API, let's say the developer wrote a bunch of new features. Essentially, I would go into, let me see if I remember how to do this. I'm not a DevOps guy, so I'm just hacking. I believe, let's say I were to add a new account, this test account, I think I can probably, let's pretend like this is a new feature within our application where I updated some code. Let's say I got user Z now. He's got that, test user Z. So I updated the code. All right, well, let's deploy this. I've got some helper functions deploy this. So if I go to our make file, I believe to deploy this code, I can hit, again, I'm not a Kubernetes guy. This is just, I thought I had a refresh command. Let's see, refresh. Yeah, so if I run make refresh, it'll basically look at the diffs in that YAML file and be like, oh, you updated code. You should redeploy your API backend. And if I get to Kubernetes real quick, you should see it doing my upgrade. So right now it's looking at the diffs. Oh, the guy updated his code. Oh, we need to update these 2 API services. And you can see a bunch of stuff turning red and no downtime. Again, if people are using our application, I just updated our code, and it's automatically orchestrating everything to deploy the code with no downtime. So you see all that fancy stuff, boom, up and down, boom, it just patched one of the API nodes. It's up and running. All right, now it's going to update the code for the second one, this second guy here, and all of the dependencies. You can see all these other pods depended on that change. And boom, no downtime, we just updated our application. Well, almost. 41 seconds up, 12 seconds. He's not quite up yet. He's Yeah, typically the downtime that does happen is when you just have a bug in your code. For instance, like if I deployed a bug, and I had 2 pods running with the API, the bug will only be in one. So it'll just be down and it'll never progress to the next one. So even if you deploy a bug in your code, it'll just take one of the pods down and it won't upgrade the second one. It'll just be like, I'm not going to upgrade because you're not healthy. Yeah, so it's kind of hard to introduce a bug into like a Kubernetes environment if you do it right. Yeah. Yeah, I mean, at that point, it's just a git revert. Like I've introduced bugs, but we have staging environment. It's very hard to get a bug into production because we go through like multiple environments and gate checks, and yeah, we have a whole CI methodology of how we deploy code, which it's a lot more advanced than check your code into GitHub and then publish Vercel app. It's a little more involved when you're dealing with these production apps.
Is Kubernetes kind of a common, I don't want to call it prerequisite, but kind of a common way of building that CI pipeline? So like you just kind of like set up your Kubernetes and then it becomes easy to like just configure like a test environment, like a production environment.
Yeah, I mean, it's all like the concept of infrastructure as code. Like once your application gets mature enough, you're probably going to want to make sure you have your infrastructure written in a YAML file in case of a disaster, right? Maybe Google Cloud goes down and your server is gone. Well, shit, we got to restore everything from backup. Obviously, we have offsite backups of the databases and the important stuff, but your code is important too. So with a couple clicks of a button, you can redeploy the whole environment. Kind of like what I demoed here is, from scratch, you got 64 things up and running. If you had to get 64 things up and running manually, I don't know how many days or weeks it would take. Like I used to work at an old company where we did a disaster recovery drill and we had to recover SAP, our entire SAP system, which is like probably thousands of different things and components and mainframes. It took us a whole week just to get that environment back up and running, like a full team of like 10 people. That's just to get the virtual machine environment back up. I used to kind of be a system administrator back in the day. But yeah, nowadays, like it's pretty much a non-event. Like if something happens, when nuke hits Google Cloud's main data center, like to get back up and running with this type of architecture, you're probably within an hour or two with 1 or 2 people probably. So yeah. Yeah.
Yeah, I have a remedial question. So like earlier you were showing kind of a system context diagram. You showed 2 LND instances.
Yeah.
So I thought I understood it's like a hot one standby like HA configuration.
Yep.
And then when you were talking a little while ago, it sounded like you were doing like the round robin.
That was just for like the upgrade. So it is always, so our node, how we have it now is we have one master node. So LND1 is our master. But if we had to patch it to update to the newest version of LND, we would switch over to LND2. So it's not like a round robin between the 2 nodes. We could do that. It's just we don't have enough load on our servers yet to have to do that, which keep it simple for now. Just hit one server and take it down for upgrades. So.
And then in the event of like a failover, how do you, it's a state channel, right? So if you have like the state has to be synced, or else it'd be like posting old states and then get,
Yeah.
like a watchtower /u.
Yeah.
How is that synced?
I'm not the DevOps guy. I'm just a front end, back end, full stack developer. I don't know exactly how, but we keep offsite backups of like all of our databases and stuff too. And so I mean, if something just blew up at a point in time, we would just recover it from our database backup. Yeah, I believe there's a way in L&D to restore from database backup. Obviously, the channels backup and all that stuff. But yeah, I think there used to be the concept of snapshots back in the day when I was like a virtual machine guy. I don't know if Kubernetes has that, like a snapshot. But yeah, I'm not 100% sure. This isn't my day job doing this stuff. I just wanted to get it out there.
So the question that he was asked is about the real-time database that is built inside the LD node, right? That keeps track of the open channels and the state of the channels.
So what I'm guessing is like probably the one of those Postgres containers is basically facilitating that. I was just curious.
But these are not possible to LD nodes.
I think it's broken. I think I'm gonna give up. What's that? We're not, it's kind of experimental what we're gonna use it for, but just a general queue to queue up transactions and stuff, just have a better way to do it. Right now we're pretty atomic, like either it happens or not, but if we wanna start queuing up data, like maybe have 10 things sitting in a queue, yeah, I'm not 100% sure what we're gonna use Kafka for, but.
Yeah, my understanding, I think Kafka is more, I mean, I guess you can use it as
Yeah, it's kind of every, it's a,
create an event-driven, like,
yeah. You can dispatch events and listen to events and listen to topics, like a pub sub queue type architecture. Yeah. Yeah, it's a good architecture, but most of our backend code like isn't quite there yet. I know a lot on front end side, like I'm a big Redux guy where everything's like a kind of a pub sub architecture of dispatching stuff and then listening to state changes, or you don't really have to listen because the selector just pulls in those state changes. But yeah, similar architecture to that. But yeah, I think, I mean, the GraphQL API, I think was the extent to where I wanted to get to. But yeah, we do, like again, we have that web wall. It's not up and running on here. Just there's bugs with cross-origin resource sharing and stuff. When you port forward stuff on local host, you run into just issues with cores. If you've been a front-end dev, I'm sure you've been there before. But
if you're deploying this to like a different, say like you went to like Azure or AWS or something, does each of those hosting providers just kind of like speak Kubernetes so that way you
Yeah.
can like give it like your whatever config files
Yeah.
and then it kind of spins up whatever instances are required?
yeah, so everyone speaks the Kubernetes protocol, but the difference between the systems is maybe you want to use like a cloud native service, like a secret store. I think it's called Key Vault in Azure. And that's where Terraform comes in handy. You can use Terraform to say, I want to use a secret store, but then you can custom configure it, say, but I want to use Azure secret store. Yeah, and it abstracts it. Maybe you want to use Google Cloud secret storage provider. So yeah, that Terraform would be the tool to kind of abstract away the cloud dependencies, I guess, if you're trying to be multi-cloud or cloud agnostic, essentially. So. Yeah, I think we're we've been going for almost 2 hours now. I guess we can do one last question. Is there any one last question? Okay. Oh man, we got two. All right, let's go. Yeah, I mean, redundancy is it's just built into Kubernetes. You don't have to. That's the whole point. Is you don't have to think about it. Yeah, you just. Yeah, I mean, it just depends on how many users you have. Like L&D scales pretty well up to, tens of thousands of users probably, but eventually like Cash App doesn't use L&D for a reason. They had to write their own software, LDK, to be able to basically horizontally scale. Just how you're storing data, how you're doing like event-driven architecture, just basically the upfront architectural decisions the developer made when building the app determines how you can host it, right? So we purposely, when we built the Galoy part of the stack, not like the Lightning part of the stack, which we don't control that code, we purposely made decisions on how we're going to host this on Kubernetes specifically. And we're getting more into like an event-driven architecture, which will allow you to scale out horizontally between tens or hundreds of different nodes. But yeah, I don't know if that answers your question, but again, I'm not a server DevOps guy. I'm just showing something because I thought there was kind of a need and skills gap within some of the Bitcoin people, but yeah, still lots to learn, still lots to do. So, all right, we'll call it good. Thanks, guys.